Alright, so to access the comment section, it's just not available right now. I can see the live chat, but after I finish the video, when it loads, that's when you'll have access to the comment section. And I'm not gonna be able to check the live chat later. Right, after the video is over. Yeah, that's correct. So for right now, you know, what we're gonna do is just I'm doing a session for pre-cal right now. I want to go for a solid 50 minutes. Okay, so another about 40 or 45 minutes. Okay. So what this is a makeup session. This is a makeup session for pre-cal, and I plan on doing one. So for all my pre-cal students, and I plan on doing one for my finite math students as well. Hopefully before the day is out. Okay, so let's just get into the material. So let's see where we left off last class. So we started section 5. Let's go like this. Okay. 1 second. Is the server not open? Oh, there's the error server. All right, let's rebroadcast this. Okay. Okay, I think we're good. So in pre-cal, where we left off, we just started section 5.2, and you know we're looking at areas of polygons using trigonometry. 1 second, I'm still kind of. Sorry about that. Okay, so with pre-cal, where we left off, we were looking at section 5.2, areas of polygons using trigonometry. And let me see. So we worked example 1, finding the perimeter and area of this figure. Okay. Let's see. Yeah, so we did this one in class, so let's just kind of pick up where we left off. So we completed examples 2, and so we want to start here with example 3 from section 5.2. Okay, let me clear this information that we're not using. Okay. So here, this example 3 says the ambiguous case. It says triangle ABC has this area. Oh, and then the previous one, I don't think we finished it all the way. It says find the area. So we solved for the triangle, but with this previous example, give me a minute, gentlemen. Sorry about that. I'm back. So when we did this example in class, we didn't answer the question all the way. And I had one of my students brought this to my attention before now. I would have given extra credit for it because we didn't answer the question. The question says find the area of the triangle. So we solved for the triangle, but we didn't find the area. So if we're going to find the area, what we're going to do is let C be the base. And so we're going to find the height. We're going to drop down that to find the height, right? So area of a triangle, you can see it. Area of a triangle is half the base times the height, okay? So that's going to be half. Our base is our C. It looks like it's a 27.8. It's an approximation, so that's going to throw things off. And then we need to find the height. It probably would have been easier if we had C somewhere else. Okay, so since we solved for the triangle, that means we have angle A, which is 88.5. So if we want the height, we can say the sine of A is going to be h over b, okay? So the sine of the 88.58 should be h over 27, so then h is going to be 27 times that. We did it in my other class. I know there's a lot going on there. So then all we do to solve for the height, it should be 27 times the sine of 88.58, and it's going to be in mode. We need to be in degrees. Okay, and we'll get something close. It's about 27. 26 point that. Let me see. So 1/2 the base times the height. So that's an approximation. So then if we said the 1/2, the base is 27.8, and the height is that answer, then we get an area of about 375.2. So we get, this is approximately 375.2 feet squared. Something close to that. You know, it's an approximation. So that's just to kind of close out that last question that we didn't finish in class. So now we're here on this example. It says a triangle ABC has an area of 6 square feet. It says the length of two of its sides are 4 and 3. Find the measure of the angle between. Find the measure of the angle between these sides. Okay. So we're gonna open with just a general triangle. We're just gonna start with just drawing a general triangle. Okay. So I'm just drawing a random triangle. No special properties or anything. I'm just going to label it A, B, C, right? It says ambiguous case has this area, the length of two of the sides, find the measure of the angle between these sides. So it says side A is 4 and side B is 3. Find the measure of the angle between these sides. So we want to solve for angle C. All right? Let's see. If we want to solve for angle C, what's the time looking like? About 12 minutes. Oh, and then we have the area, okay? So we have that the area is, which is 1/2 the base times the height, should be 6. So we can let the base be 3. If we let the base be 3, then we got to calculate or solve for the height. Okay? So if the base is 3, let's plug in what we have. So at this point we have 1/2. We said the base is 3, we don't know the height, and the area is 6. So now if we solve for h is going to be 6 times 2 over 3. That's what, 4? The height should be 4. Something interesting is going on. Should be a right triangle. Let's see. If the height is 4, oh, and then now we want to solve for angle C. Okay, I think I have an idea of what angle C is now. Notice that the height is 4 and the side A is 4. So I will open this up for extra credit. If any of my students, my clock right now says 3:40, I'll give you until my clock says 3:43. Can somebody tell me what is the measure of angle C? If you can hear this, what's the measure of angle C? So I'll give you 3 minutes to see if you can find that solution. And I'm going to move forward and come back. So can you tell me what is the measure of angle C? We said that the side A is 4, the height is 4. So then could somebody tell me what's the measure of angle C? All right. So you still have like a solid 2 minutes to answer that from right now. Okay, so if anybody can get that. So let's keep going. So we still got about another couple of minutes. So I'm going to move on to the next one. So this one says find the area of a triangle where angle A is given, B and C is 18. Okay, so let's draw a general triangle. So I'm just going to draw a general triangle. So I'm just going to label A, B, C. So this is going to be our side A, this is our side B, and this is our side C. So side A is opposite of angle A. Now we're given angle A is 63 degrees. We're given the angle B is 74 degrees. We don't, so we can find C really quickly. So to find C, can somebody tell me, if you're listening, how do we find angle C? Okay, so my clock is about to say 43 after. I'll give you until 46. How do we find angle C? That should be a pretty easy Easter egg. I'm going to go back to the previous. Okay, so here, if we see that, side A is equal to the height, then it lines up. And so there's only one triangle possible, right? And then, so that means that, so this extra credit is off the table, but that means that angle C should be 90 degrees. But even if we didn't know that, we get that the height is 4. So then if we want the angle, based on the drawing, we would say what? We would say the sine of C would be H over A. So then that means angle C is going to be inverse sine of, what's H? We said H was 4, A was 4. So inverse sine of 1. So in other words, we're saying sine of what angle gives us 1, then we would say that theta equals 90 degrees. Okay, so C is 90 degrees because A was equal to the height. So a triangle has this area. Find the length of the two sides, or find the measure of the angle. So the measure of the angle is 90. Okay. Okay, I have somebody submitted something. We said that C is 43 degrees. Mr. Hardy, how did you get to 43? Okay, so those points are still good. How did you get 43? Just real quick, how did you get 43? Okay, let's see if we can confirm the 43. Okay, so I will, the interior angles add up to 180, so yeah, so we say the 180 minus the two angles. Okay, so then we'll say 180 minus 74 minus the 63. It's 43 degrees. Okay, I can get down with that. So we're going to put that in blue just in case we made a mistake, so we know that can be a potential source of our error. And that was Mr. Hardy. So D. Hardy. So D. Hardy. All right. So copy so we can reference it later. Oh, we didn't need to do that. Okay. So now find the area. So we want 1/2 the base times the height. Let's see, can we find the height? Can't find the height just yet. Can we solve for one side? Can we use the law of sines? Oh, we have that C is 18. Okay. 18 inches. So is this the ambiguous case? No, because it's angle side angle, so we're okay. So we want to find the base B. Maybe we can use, let's try the law of sines. So then if we want B, we can do B over the sine of B should equal, we're going to use C, which is C over the sine of C. Okay. So time like 20? Okay. So then ultimately, side B, we're going to say the sine of angle B, which is 74 degrees, times C, which is 18 inches, over the sine of angle C, which is 43 degrees. So then side B, mode, we need to be in degrees. Okay. So the top is, we're going to say 18 times the sine is 74. That goes to the top, divided by the bottom is the sine of 43 degrees. Okay. So we get that side B is right at 2537 inches. So we said 2537 inches, and it's approximately. Okay. So then can we find the height? So we want to find his height, right? Okay. Let's use the 63. If we use the 43 and we took the sine of that, we don't know A. So, but if we took the sine of 63, that's going to be h over c, so we can find it. So the sine of angle A is going to be h over c, so that means the height is going to be 18 times the sine of 63. So then that's going to be approximately, so then we just say 18 times the sine of 63 degrees, and we get 16.04. Let's put it in blue, or let's put it in green. 16.04. The units here are inches for the height. – 16.04 inches. Let's kind of move that up. So. Let's get some power. Okay. So now, we have that the height is approximately 16.04 inches, right? So the area of the triangle is 1/2 the base times the height, so it's going to be 1/2. The base is our B, we say it was approximately the 25.37. The height is the 16.04, and we'll get our number that way. .37. So then let's do the 1/2 parentheses. I want to say 1/2 times all of this. The base, and then the height is, it should still be the answer. I think this is 203. I think that's okay. So just keep me honest. If I make a mistake, if you got a different number, if you can bring it to my attention and convince me, because it could be a mistake in there. I'm gonna let you kind of check it, double check it, and make sure it's correct. 203.45 inches squared is the area. 203. Okay. Because I don't, I could have done an error in the calculator, but so I'll let you guys discover that. Okay. I think that's that example. Let's move on to the next one. That's number 5. Okay, so this is an example on the Heron's formula. That one, I'll just let you use it. Maybe your presenter could do a demo on it. I'm just going to work this in the way I'm used to doing it. But there's a formula that kind of takes you directly there. But I'm going to just use, the stuff that we've been talking about instead of Heron's formula. You can use either technique that works for you. So first, I'm just going to start with a general triangle. So nothing, no special anything. So I'm just going to label it A, B, C. So it's not necessarily drawn to scale. Now it says that side A is 11 meters, side B is 17 meters, and side C is 20. Now since C is the largest side, I'm just going to, based on my drawing, I'm just going to move it over. I'm just going to move it down here and move B over here. So if my side B is there, that means angle B needs to be here and angle C needs to be here. I'm just doing that just to try to keep it a little to scale and keep it making sense. Okay? Find the area. So we need the base, we have the base, and we need to find the height. So then the height. So then we need either angle A or angle B. So if we're going to find angle A, we can't use the law of sines. We don't have enough information to do the law of sines. So let's try the law of cosines, right? So if I want to find angle A, so then if we use the law of cosines, we're going to say cosine, no. We're going to say A squared equals B squared plus C squared minus 2BC cosine of A, right? So we're going to solve for angle A. Now side A is 11 squared, B is 17 squared, C is 20 squared minus 2 times 17 times 20 times the cosine of angle A. So then the cosine of angle A is going to be that 11 squared minus 17 squared minus 20 squared divided by a negative 2 times 17 times 20. Okay, I know it's going off the screen. And then we take the inverse cosine of that. So then we get the angle A is approximately, so we're going to say inverse cosine of, now the top, it's 11 squared minus 17 squared minus 20 squared. That's the top. Then divided by the bottom, negative 2 times 17 times 20. This closes off the bottom. Then the next one closes off the inverse cosine. And so our claim is that angle A is about 33.35 degrees. It's at 33.35 degrees. Okay? So then if this is angle A, if we want to find the height, the sine of A equals h over 17. So then h is going to be, h is going to be 17 times the sine of A. It's going to be 17 times the sine of that 33.35. So we're going to say mode, we're in degrees. We're going to say 17 times the sine of that answer And the claim is that the height is approximately 9.347 meters. So then, if we want the area, so then area of a triangle is half the base times the height. So we're saying half. Now we define the base to be 20 in our context, the way we have it drawn. The height we calculated to be 9.347. So that's going to be approximately. So if we said 1/2 times 20 times that answer, our claim is that the area of the triangle is 93.47 approximately. 93.47 meters squared. So again, I'm not going to check it right now, just for the sake of time. I want you all to check it, maybe look it up, research it, see if you can find this, and make sure that the numbers match and are equal. If they are not, if you can correct it and bring it to my attention, I'll offer that as extra credit. Okay. All right, let me shrink. I would like to shrink all of this to the same page, so we're not spilling over. So there's a copy of what we just did, a little bit more concise. All right, let's see, it's been about 30, so let's keep going. So that closed out section 5.2. Now we're ready to move into 5.3, Trig Equations. So this section comes, this is a supplemental material. It comes from another text that we use, and so a copy of this text is actually found in our box folder. If you go to the box and handout section, you're going to see a 5.2/5.3 handout. So this is in the handout section. So you have a copy of this. Excuse me. You have a copy of this that you can use. Okay. So it's in the box. You want to check box. All right. So we're looking at trig equations. So it says find all solutions of these equations. Now, when we think of trigonometric functions, like for instance, sine of x, when is sine of x 1? If we think about the graph of sine, so let's kind of draw a quick picture. If we think about the graph of sine, right? Sine, so we have what, the 90, 180, 270, which is 3 pi over 2, and then 2 pi, so on and so on. We have 1, negative 1. So sine starts at 0 at the origin, then goes up to 1 here, and it doesn't get back to 1 until you get to the right side of it. So after we go 360 degrees, we'll be back to 1, right? So notice there are infinitely many x values, then when we plug it in, we'll have an output of 1. So to solve the following, what we want to do, the following. Sine of what angle gives us 1? So we know that sine of 90, so for part A, so we know that when x is 90 degrees, that'll give us 1. But then it's going to repeat every 360. So we're going to say plus 360 in degrees. But then the question says to give it in radians, so we're just going to convert all these to radians. This is going to be pi over 2 plus 2 n pi radians. So where n could be any integer. So for instance, if you let n be 0, now we're at sine of 90, sine of 90 is 1. If you let n be 1, we're at 360 plus 90. So, you can plug in any value for n, and in this case, the output should be 1. Okay? I don't really plan on checking these, so you want to check them and make sure they're correct. If you find an error, bring it to my attention. The first person to bring it to my attention, I can give you some extra credit for that. If we're looking at B, cosine of what angle is 1? Well, cosine of 0, cosine starts at 1, and then it doesn't get back to 1 until we've gone 360 degrees, right? So then B, we would say x would be 0 degrees, again, plus 360 in degrees. Every 360 degrees, we're back to 1. But we need to convert this to radians, so that's just 2n pi. Because the first one goes to 0. So if n were any number, when we plug it into the second equation, output should be 1. So then tan of what equals 1? So remember that tan is the slope, and it repeats every 180 degrees. Right? Tan of 0, or tangent at the origin, is 0. And then that pi is going to be a 0. Say pi over 2. We're going to have an asymptote, so then it should be pi over 4. Another way we can look at this, so if we're doing C, if we have tan of some angle equals 1, well, this means that sine of some angle over cosine of some angle should be 1. So when do we have a slope of 1 for tan, and that is at 90 degrees. So x is, 45 degrees. But x is 45 degrees, okay? So we would say let x be 45 degrees. Convert that to radians, it would be pi over 180. So we would say 45 divided by 180 as a fraction. So that's pi over 4. So 45 degrees, and then tangent repeats every 180. So we say plus n pi. So this captures all of the solutions that work. Now we can check this. For instance, the first one, we say let n be any number. So if we go to y equals, and we're saying sine of x, right? And we're in radians, so we're good. So we go to variables, y1. Now we said x can be 90 or pi over 2 plus 2 n pi. So I'll choose n as my 7. I'm just choosing a random n. So we're going to say y of pi over 2 plus 2 times 7 times pi. And we should get a result of about 1. Okay. Oh. Okay, gentlemen. I have to do this. So right now there's a live event. Okay, maybe I can just do it here. What time is it? Oh, what's that? That's the camping going on right now. Is that going on now? Let me see. Give me a second. That should be tonight, not right now. Uh-oh, it looks like it is live. Okay. So, there's this game called HQ, and what time is it? Okay, so we still got about another 20 minutes. There's a game called HQ, and it's live right now. They got a huge pot, the biggest pot that they've had. This is going to be like $300,000. It's up for grabs. If you answer all 12 questions right, you get a portion of the prize, and it's a free app. It's called HQ. If you're interested, just let me know. But anybody can do it. It's just a free app. But back to this question, I think we're good with these. So just check it. Try to keep it honest. I posted some assignments on this, and usually there are ways to kind of get some help with these. Let's try another one. Let's do another one. We only have about another 10 or so minutes on the clock, but let's keep going. So if we look at this example 2, let's go back to this. Okay. So part A says find all solutions of secant x equals 1.5 round solutions to the nearest 10th. Okay. So if we're doing A. So we have secant x equals 1.5, right? But secant is what? The reciprocal of cosine? So this is really 1 over cosine of x equals 1.5. And then if we flip both sides, then it's just 1.5 is actually what? 3 by 2? So this means cosine of x equals 2 by 3. So then cosine of what angle is 2 by 3? Round solutions to the nearest 10th. Again, cosine repeats every 360, so we're just going to take the inverse cosine of this. Two over 3. I think we need to be in radians. I think we have to be in radians. Let's leave it in radians. Let me do something else real quick. I want to put it in degrees so I get a sense of what's going on. So we're at about 48 degrees. Negative 1 to 1. 0 to 180. Okay. So then in radians, instead of the 84 or the 48, we're going to do the 0.84. It said how many decimals? 10th of a degree. Oh, degree. Oh, so we can't use degrees. Okay, so we can do 48.2 degrees. So then x is approximately 48.2 degrees. But then this repeats. If this is cosine, it's going to repeat up to 360 degrees. So we're going to say plus 360 in degrees. So we can check it. The best we can do to check is that when we plug it into cosine. Now we can use something called MathWay and plug it into MathWay to verify, because we can do actual secant of our answer in MathWay. So let me do MathWay real quick just to check this, since we're at home or we're just kind of relaxing. Okay, I would like to go to MathWay. Now, if you're on an exam and you wanted to check something like this, the best you can do is check from line 3. It's a few solutions in there. I want to go to Trig. Okay. So then, what I want to check is secant of. We're gonna do the 48.2 plus. I'm going to choose a random n. I'm going to choose 11. So we're going to say plus 360 degrees times 11. Okay, and the result we should get is 1.5. Oh, wait a minute. Do we need to be secant 48.2? Let me think about this again. I probably should do my domain and range. Let me do the domain and range because I was trying to avoid it and skip it, but I probably should do it. So now in the past when we did inverse trig functions, cosine of theta, the domain goes from 0 to 180 inclusive, and the range went from -1 to 1, right? So then for our inverse trig, this is our range, this is our domain. So when we do inverse cosine, it has to be between -1 and 1. It is. So then the output has to go from 0 to 180, and it does. Let's see. What else am I missing? Do I need to evaluate this? Sorry, I'm a little distracted. The game is on. 4 point. Let's see. Let's see. I feel like I'm missing something. I'm not sure what it is. Let me try it one more time. Give me just a few more minutes. So as I see the time, I want to simplify. Okay, let me try one other thing. Sorry, my computer's moving slow. We're about to wrap up. Okay, let's try one more. So if we said secant of 48.2 plus 360 times 11. Just want to evaluate. That's one. Can we? What else could I do? So instead, let me do the following. 1 over the cosine Okay, there's something I'm missing. You got to give me a minute to think about what I'm missing. So do I have a solution here? I think I do have a solution here. Oh, yeah, that's what we did. I don't know why this isn't working. Oh, okay, there are two solutions I think that'll work there as well. So cosine is positive in quadrants. Cosine is what our x is going to be positive in quadrants 1 and 4. So there's a quadrant 1 solution, which is the 48.2 degrees. So we need to be 48.2 degrees. Oh, I missed the first question. I got distracted. Oh, well, that's the end of that. That's another reason it's taking so long. I was trying to answer this first question. But we need to be 48.2 degrees away from the x-axis in quadrant 1 and 4. So the quadrant 4 solution would be the 360 minus the 48.2, and we get the 311.18. Give me a second, gentlemen. Okay, so this is the quadrant 1 solution again. So cosine is positive in two angles, in two quadrants. So we have quadrant 1 and quadrant 4. So then the quadrant 4 solution, we would say the 360 minus the 48.2, and we get the 311.8. Okay. So there are multiple angles that are going to work. It's going to be 311.8 degrees. Again, plus 360 in degrees. So I'm pretty sure I may have made a mistake in the one before. So, you know, check it out. Let's go back and look at it now. Yeah, if we're doing 90, I think these are okay. Because it doesn't have the two solutions. But like this one, cosine is positive in quadrants 1 and quadrant 4, so we have two solutions. We have a quadrant 1 solution, a quadrant 4 solution, and we get these. But the only thing I'm having trouble with, when I check it, I'm not getting the result that I was anticipating. That's what's like throwing me off. 48.2. Only other thing, maybe I just need to convert this to radians when I do it here. So let me check here one more time and do it in radians and see if that'll fix it. Secant pi over 180. So if we said the 48.2 times pi over 180. So now it's going to be in radians. Okay. And then we wanted to say plus 2 pi, that's not pi, 2 pi, I'm going to say times 11 just to throw that in there. All right, so I converted it to radians. Let's see if that fixes the problem that I was having. We should get 1.5. I just want to evaluate. Okay, so the problem, okay, I couldn't figure out how to change the mode in this math way to degrees, so it kept thinking radians, and that's why I was throwing it off. So we did it, we converted to radians, it worked out, we got the number we're looking for, and let's just check this other one. So we did the 48.2, let's check the 311.18. 311.18, and I'm going to use another integer. I'm going to choose negative 27. I'm just choosing random ends. Just to make sure that it works. So again, we should still get a positive 1.5. We just want to evaluate and okay. Decimal form, secant. Let me see something. Negative 27, 318. Was it 311? 311.8. This one's a little off. Let me see if I put this in parentheses. I just want to evaluate. Okay, it's still being off. 311 pi over 180. Instead of using such a large number, let me try something like negative 7 to see if that makes a difference. Evaluate. Because I was using kind of an extreme number. Yeah, it's probably that negative 27 was just too extreme. Because, you know, we have some rounding, so the further away we get from the original, then it's going to skew it even more. So that's probably why the 27 wasn't working. I know it was a little bit dicey. You're going to have to do the best you can for the weekend. Okay. And we'll pick this up next time we meet. All right, gentlemen. So we will actually, oh, did it stop? Yeah, we're good. So we will actually end the session here, okay? And so from one beautiful mind to another, enjoy the rest of your day.